Thank you, thank you, thank you. So what are y'all's questions at this point, having looked at it for a hot second?
It's the same thing.
What do you mean?
It moves constantly like the y equals x, it moves just like it. The one that give you on the thing as for 7 points,
Mm-hmm.
it do the same thing as the one we did. If that makes sense.
I mean, we started with the y equal, remember, so we did x times h of x, right?
Mhm.
So like we did do that. This is just a different function here than what we had before. Before we had x plus 3, right? Now we have
Negative equals everything down
the opposite of x plus 3, or the negative x plus 3, right? So it does change things. But I need y'all to pay attention because there's multiple ways to do this, and it looks like a whole bunch of us are getting stuck. Okay, or making it a little bit more difficult than we had to, right, Anthony? Were you doing making it more difficult than you had to on that table?
I don't know. Probably.
Yes. Look, for those of y'all that are trying to make a table, what I need you to remember is, for every table, what do you need?
Numbers.
Yes. You need x and you need y. So x, and I'm going to put h of x up here, which that h of x is negative for the opposite of x plus 3. And so, I don't know, I saw some people starting with an x value of negative 7. Could you substitute that negative 7 in? Yes, you can. Now, don't do that. That's harder than it has to be. Pay attention. What is negative 7 plus 3?
Negative 4.
Negative 4. And then we just have the opposite of negative 4, which is?
4.
Can anyone tell me right away why that should have made sense and why I did not need to substitute it in? Say again, Jakyle.
What?
You said it on why it should make sense, but it's not.
Oh.
So, we should have known that right away without having to substitute that negative 7 in.
Because they give it to us
Where?
on the line.
Which one?
Oh.
The black line.
That one here?
Yeah.
So I go to x value of negative 7.
Yeah, it's already on there.
Oh yeah. Because remember, y'all, this is the line y equals negative x plus 3. Every point on this line should make that equation true. Right? That's it. So I didn't have to do all of that work. You can, but notice the last detail is x times h of x, and so you would just multiply those two. That's what you're doing if you're doing it tabularly. But remember, they also gave you very clear instructions up here. What's another way to write x times h of x? What's another way to write x times h of x?
Dilate by x.
It's
Well, but it's h of x. It's the function h. What is that h? What's another way to think of h of x? Oh, that's equivalent to x times y, right? Oh wait, so you're taking this negative 7, the x, and you're multiplying it by this y of 4? That's it. What does that give you? Okay, so Kyle knows it's negative 28.
Oh yeah, because you multiply.
Yes, it's x times y. Now, can I graph that point?
No.
No.
Thank you. So am I going to worry about that point?
No.
So what about here? Negative 6 comma 3. Gives me negative 18. Can I graph that one? So am I going to worry about it? Negative 5 comma 2.
Negative 10.
Negative 10. Notice I even know that. It'd be still an x value negative 5, negative 10. It'd be roughly here. I don't have that really, so that probably isn't the best point to graph. But negative 1 or negative 4, 1. Right? You don't have to make the table, but you can. That would give me negative 4, negative 4. There's my point. That's the first real point, and I would probably use something different. But negative 4, negative 4. Right there. Okay? That's negative 4, negative 4. You're dilating x times y. That's it. Use a table, use a graph, do something, but let's get going on it.
I see.
The graphs are pretty small, so we shouldn't need too much work with the calculator to make it work. Yes, sir.
So pretty much I did, basically, I did this right.
Keep it going. Now, you can't have a negative 0.
I know, you talking about this? Or you talking about this?
I don't know that. What's the pattern that's happening with your x values?
Exactly.
No. Look at the pattern that's happening with your x values.
It's going down.
Because, and this is a common issue that a lot of y'all are making. You're looking at this point, I assume, right? What is that point?
0.
It's cool.
You talking about on this?
Yeah, what is that point? No.
It's just 0.
No. Remember, you need x first. What is your x value?
3.
But it's to the left, so it's negative 3. What's the y value?
0.
Right, that's where the 0 came in. So the x was negative 3. Literally, look at your x values. Would it make sense to put a 0 here when you're just adding 1 to every x value? No. Look at your y values. Now notice we're not multiplying those yet.
I know,
The
I
y
was
values
just
is-
one example like you just
Gotcha.
said.
But you could write off to the side negative 7 times 4 to get that. There you go. But notice what's happening to all your y values here. Subtracting by 1. Right? So keep that going, I think. But you also need to be talking with your group. This is the last question I'm answering until you talk with your group for the future. Okay? I need y'all working together. Oh, 1 second.
I got a negative 4 out.
You can't have a negative crowd. Okay. What now?
Take down.
Answer the rest of the question. Find out why. Is this making more sense now? Kind of ish. So you can start graphing those points. Now, what I'll point out is, it probably doesn't make sense to skip, I just did it because I knew I couldn't graph the point. But keep it going, right? So you looked at negative 4, 1, so you use the next point, and then the next point, so you can graph your parabola. Okay? Jenny, do you understand what you're doing? Make sure you're working with your group. I mean, I would keep it going until you can't graph another point. We're trying to get the dilation of x times h of x.
And you just graph it.
So look at those next few points in there.
Anyways, we confused, well, not confused, just mom. If we ever got these bricks from these points, you just need to do the table, right?
Do you have to do a table?
No, you don't do that, but it said dilate is
Right. So, remember, this is literally just y equals x, okay? So, what you can do is, the reason why I drew this line out here is we're going to talk about in a second. You see how there's this point? See how there's also this point? Well, that y value is the same as the x value, correct? So, this y value is 1 times this y value of negative 4 gives me negative 4. Notice that's the same as taking this x value and multiplying it by that y value. So the x value is negative 4, the y value is negative 4, so that's the first point of your parabola.
So basically, we already did.
That's negative 3 comma 0. X times y gives me that same point. Now this is where it starts to change a little bit. That's what, negative 2, negative 1. X times h of x gives me a positive 2. Now this is the reason why I recommended the table, just because it can start to get kind of messy if we look there in the middle. But you just need to keep that dilation going. Ishmael, what you doing, buddy? You've literally just written down what I've written down for you. That's it. Have y'all talked as a group? Huh? Okay, well, I'm gonna move forward in a minute. I'll come back and check on y'all before we move forward, but I need y'all to talk with each other. Can't help you if you're not talking. Yes, ma'am. Have you talked to the group first? So have all four of us talked about number 6? Yeah, you haven't even graphed any points yet. You haven't done the h times, no, you made a table, but you haven't done h, or x times h of x. I need you to graph it, that was all. Oh, okay. But she's already on number 6. Wait, you haven't graphed either. No, I need you to graph these points. Graph the points first.
So, I have to start my graph because normally, like on other stuff, like the stuff that we did before, we use the x values of
That's just the parent function.
Yeah,
You can do more.
yeah. So I decided to expand a little more.
Or you can do that.
But wait though.
Q1, you talking with a group at all? Also, I need your hood off, please.
Yes, so that's coming from what point is that? So that'd be -2,
Anthony, have you talked to the group, or you just finished and you're done?
Oh, I'm done, I already talked to them, they said fine.
You want to re-examine 6 and 7? You didn't answer the first question.
Write the equations.
Have you ever written a function at that way of x times h of x? What could you substitute in for h of x?
Oh, sorry, -1, -2, right?
You need to re-examine numbers. You're close. Oh, wait. Actually, you need to re-examine your graph. Couple of things. Have you actually taken these points and graphed them?
You're trying to decide what point to use.
No, I'm trying to see -4. I don't see that point on there. I don't know, I might do all the points and check to see what the graph like is. You have some correct ideas already, but if you actually graph those points, you'll see. Alright, have y'all talked with each other yet?
-4, all the way down to the
So why'd you only look at those points? And that's all you would need to recognize, is
That's
right?
what I was-
It's like if you look
that's what I
at,
was
you
about
can't
to
do the
do.
-18, you can't do the -10, so you just graph the ones you can graph.
Okay, so we're supposed to start at -5 and
That's why I asked her, I was like, which ones did you like? Because I was like,
Need y'all to look at 6 and 7. After you get those graphs done. Ishmael, what have you done since I walked away?
Nothing.
I cannot help you grow and learn. Huh? Okay, have you talked with anybody in your group yet to figure it out? I will help you as soon as you talk with those in your group. Come on, you gotta quit doing this to yourself. You're more than intelligent enough. Did you actually graph your points? I'm so.
I was asking about that.
What do you need? You just asked me about that.
I asked you about the graph report. That's why I called him up.
and I left you with the idea of graphing points.
And I did, but most of them the same as these points. When I went
They're
back on
not.
here,
They're not.
them the ones you
That is -4, right? -4, I gave you this one, -4 times 1. This is -3, 0. And so that gave you that same point again. Then this was -2, -1, which gave us -2, 2. Then I look at this point, which that's
But that's
that
not
1, -1, -2. 2 again. But the answer is -1.
But that's making such a difference. Oh, is that making a parabola? I mean, a use this one is gonna make
That's what? What are you looking for? Why have you not graphing this function yet?
Oh, you got that graphing, but I'm kinda like stuck, cause it doesn't look right.
Well, your points are right.
Is it process?
No. When the x value is -4, what's your y value? 1. When your x value is -3, what's your y value? Okay. That kind of makes a difference. You don't need the parent functions.
Mr. King,
Sir,
I have a question.
must go over some stuff. You talking about this method actually?
He asked me a question, I'm sorry.
Okay, y'all.
Yeah.
A lot of us did not pay attention to the directions I gave you. I need your all eyes up here. What is this function doing? We're dilating h of x by what? X. So, I told you you could use whatever method you want. I don't care, but you got to do something. I'm tired of walking around and it's been 3, 4, 5 minutes and we haven't even progressed forward at all. It says sketch the graph. And a whole bunch of us haven't even come close to sketching a graph yet. When I look at this point right here, which I could have looked at this point as well, and we already did that. This point is -5, 2. Which part of that point is my h of x?
Doing
The -10.
H of x, ladies and gentlemen, remember it's x times h of x.
Oh, the 2.
The 2, remember h of x is my y value, or the output. The -5 is the what?
X.
So, -5 times 2 is
-10.
-10. So there's a point somewhere down here that I don't really know. What's this point?
All.
-4, 1.
What's -4 times 1?
-4.
So the x value is -4, the y value is?
-4.
Boom. Then I look at the next point on this line. That's what point?
-3, 0.
And I need y'all to be careful because one of the biggest issues I saw, not biggest issues, a very disturbing issue on the test was, hey, we did not write x-intercepts or y-intercepts the right way. We switched them. It's x and then y. Okay, so what's -3 times 0?
0.
Oh, so
So that's the same.
same, okay. This point right here is -2.
-2 and -1.
-2 times -1 is?
-2.
It's 2. So -2, 2. Now, this is right here why I recommended making a table, because it'll just help you organize things. And remember, as h of x, or -x plus 3. So you could have just quickly, and should have quickly, grabbed points off of the line. And you didn't, again, I just talked about this. Do you have to substitute that x value in?
No.
No. Because it's these points on the line. Y'all are more intelligent than this. This is the only reason I'm frustrated. Because I just went over this, and I had stuff up here, and then I walk around, and one, we're not talking with each other, so we're still struggling. Two, we did not pay attention to, we wrote down exactly what I wrote on the board, but we didn't pay attention to what the whole point was, or why we did these things. This point, right, -1, -2. By the way, does anyone see a pattern here to help us keep it going so I don't have to keep going back to the graph?
-3, -4, -5.
Remember, math is the study of patterns and relationships. It's just subtracting 1 every time. Because what's the slope up here? -1. That's it. And so x times h of x, -4, 0, 2, 2, 0, -4, -10. I'm going to stop there. Anyone know why?
Because you got all the points.
I can't even graph -10, right? So there's no point. Notice the next one would be -18. By the way, did any of y'all go back to number 4? Handful of us did. I can tell by the way when I walked around, for most of us, we did not go back here. When I took x plus 3 and I dilated it by x, what type of function did I get?
Parabola.
Oh, parabola. Any guesses what I should get here?
Parabola.
Oh. Now, I want to point this out. Don't draw this because it'll be wrong. Is this function going to do this? Why not?
Because it's not just straight down.
Notice that's not straight down. That's not the
I
issue.
don't think that's what you're getting at. This is no rectangle.
Yeah, guys. That it's supposed to be a parabola, right?
Oh, yeah.
Is this going to be a straight line right there?
No.
No, it's going to have a vertex. Do you know exactly what it is yet?
No.
Does anyone have an idea how we could get it though?
The calculator.
How?
I don't know.
Okay.
You go to menu.
But we don't have a graph on the calculator, do we?
You have that.
How?
I know how to do it.
Then do you actually know how to do it?
Yeah. Oh.
Remember, you need an equation. Do y'all know already what the equation is? Thank you. Hey, how do we get every other point?
Oh! We just
Multiplied
By x times y.
x times y. Hey, this right here, the x value is -1.5. What's the y value?
-1.5.
Okay, so what is it? So the x value is -1.5. What's the y value? Come on.
-1.5.
No. Remember, we just said we have to dilate the
What is
x
possible?
by the y, right? Or the y by the x. So we need -1.5 times.
2. -1.5
Did I just
times
say
2.
it?
It's -1.5 times -1.5. Remember that point right there.
I did too. I asked for that wrong.
Okay? So 2.25. 2 1/4. Roughly. But it's a parabola. 2.25. If it does not have a vertex, it's not a parabola. But it does have one. Remember, it's just taking the x value and multiplying it by the y value. And we just hadn't done that yet, but it does have a vertex right there. Boom. Now, there's a couple ways to approach this one. I want you all to look at number 6. I want you to take 30 seconds to try to figure out what the equation here might be. A bunch of us actually are very close already. Notice I don't want it as x times h of x. I want what could go in the place of h of x. Okay? And then we will move into number 7. But take 30 seconds, try to write an equation for 6, and then I'm going to have you talk with your small groups, and then we'll come back together for a whole class discussion. So, 30 seconds. Go. You
Would
can't
it
just do a
be,
general sketch. You need actual points and be accurate.
would it be, the equation from the first one, from 6, I mean, 5?
I mean, do we have, wait, 5 or 4?
Well, it's 5 on my page.
Yes, it's from 5. But it's not going to be times h of x. Think about that parabola. Think about what we could do.
I'm saying, like, the equation that you put right in, you got negative, and then you got the x plus.
You made your life hard. I had to be on that one, Sharnavia. It works. But, look. So we'll talk about this in a second. J of x. We already know it's x, right? Times h of x. What is h of x the same thing as?
Why? Why?
Don't we already know what h of x is? You need to be careful. That is not correct. 1, negative 4. It's not flat along the top. What is h of x? Negative.
Well, you got a
Literally, from the very beginning, they said h of x was negative parentheses x plus 3. Now we're going to talk more about that in a second. But that's it. That's all you have to do. And we'll talk about how that connects to what you did in a second. Okay? So what you did is correct, but it could have been easier. What's your question? You're just shaking your head. You need to work on fixing that graph. Alright, talk with each other. Make sure, check, see about your equations.
Why we got a TV?
So
Why we got a
I think that
How does j of x equaling x times h of x? Focus on your math. How does that connect to this?
Only like a few on supposed
You can't do it that way, but you're making your life way harder than it has to be.
Yeah, cause she was like, what she gonna do? Yeah, but like, you can do everything.
What do you know about h
You
of
can
x?
buy boots.
what we have here for x times bunch of that.
But they wouldn't buy nothing for supplies or something. They wouldn't buy TV.
I think I have it played, but I'm not sure.
TV, they buy TV.
Thank you, thank you, thank you. Alright, so I want to show y'all an equation that I saw one group come up with, or I'll slightly modify it to make it a little bit more accurate. I saw this equation.
That's what I was asking you.
So that's an equation.
Bro, I had asked you, but then you had turned your back on me.
Hold on. Stop. Stop.
I'm so serious.
Okay, congratulations, but stop. This is an equation I saw a group come up with.
Yeah, that's
Not necessarily saying it's wrong, but it's not what I was asking for here. Anthony, why do you think that's good?
because that's that's a translation. I mean, that's a quadratic function.
Okay, so we have, notice, you can see that, well, first off, what form is this?
Huh? Vertex.
Vertex form, right? Was it translated to the left, 1.5?
Yeah,
Translated up, 2.25?
yeah.
Yep, notice that's my vertex idea. And then reflected, you'd have to do some work to prove that A is -1, but yeah, I mean, that does work here.
But it should be j of a equals x times y.
Well, so this is what I want to point out here. So j of x equals, remember, this is what I was asking you to focus on. X times y. And I think, Sharnavia, you went into a lot of detail where you did the factored form, right? Because what did you notice here?
They had 2 x-intercepts.
Right, 2 x-intercepts. The first root we could say is -3, the second root is 0. Right? So can you use factored form here?
Yeah.
Sure, 100%. But again, y'all, making your life too hard. It it literally says right here, j of x equals x times h of x. X times y. So we still have x. What is another way to write h of x in this problem? Kelsey, I need eyes up here. What's a way to write h of x in this problem?
Why?
Yes, that's equivalent, but look at number 5. What is h of x equal to?
X.
X plus 3.
Negative x plus 3. Isn't that h of x? Done. I would probably put brackets around here to point out that those go together, but that's literally h of x, isn't it?
Yeah, man, but I don't know. I don't know. You be making us think hard. I don't know.
Okay, so the first class.
First of all, when you get this, oh,
you just
right
gotta
here.
do.
This equation?
Yeah, you gotta do extra work to find what A is, but you can work.
100%, right? That can work. Now, I will point this out. This will not help you learn what I'm trying to get you to learn out of this, but that equation works. That's vertex form. It works, right? It's not going to help you learn what I want you to learn out of this. What I want you to see is that this x right here, where do we see that on the graph already? Does anyone
That
see?
That line,
Which line?
the one going
The
down.
first one that they gave.
Not y equals, not the y equals, y, the second one.
The negative x plus 3.
Blue, black, or red?
Black. Is it black?
This x is the black line?
No, it's the blue line.
Okay, that's my blue line. Right? That is literally y equals x. That's what I want you to see there.
Yeah.
This right here, the negative, parentheses x plus 3, that is the
Black line.
black line. That's h of x. And we multiply them to get what? The red line? Red parabola?
Ooh.
Can we call it a line?
No.
No? We can call it a parabola or a,
Concave up.
or a what? Concave?
Down.
Down curve. Which, Anthony, this freaked you out at first. You were like, Mr. Kinney. Well, first off, you said negative parabola, right?
Yeah.
We need to be careful here. This is not a negative parabola. What is negative?
It going either up or down.
Okay, but what is negative?
It's like to the left.
So and this is what I'm trying to get you all to
how much
understand.
is over?
I need you all to understand very clearly, concavity is not negative or positive. That was something I saw a lot of students making a mistake on. Concavity is either up or down. So what is negative? A is negative. We've got to be careful about that. The A can be positive or negative. That's what makes the concavity up or down. What are your questions from here? I know, Mr. Kenny, I got no questions, and then I get to doing the work, and I have all the questions, and I don't want to ask anyone questions.
A is always negative.
That's how it
A can be positive or negative. If A is positive, the parabola is concave
Oh.
up, and if A is negative, it's concave down.
So A is the determination of the correct.
Is determines the concavity. Because remember that A also connects to the reflection. If A is positive, it has not been reflected. If A is negative, it has been reflected down. Right? All those ideas connect.
Yeah, that's why distribute, like, it's just like order of operation.
Say that one more time. We can what here? I want y'all to notice what Anthony just said, and you should show this here for number 6. So one of the things that I would have done is I would have rewritten this with the negative out in front. Then times x plus 3. Charnavia, does that look familiar? That looks just like the equation you wrote, doesn't it?
Factor form.
For factored form. Charnavia went into a lot of the work to write it from factored form using the roots that we've done before. But I want to point out, all I did was, this -1 is understood to be multiplied here, so I just switched the order of the negative and the x to get that factored form. That's exactly what that is. You can also, Anthony said it earlier, starts with a D, do what?
Distribute.
Distribute. What's x times x?
X squared.
Uh-huh. So I need the negative still out in front. X times 3.
3x.
And then I would need to distribute the negative to everything, and so I would get,
Negative x squared plus, no, minus 3x.
what form do I now have?
Let me see.
Is this
Oh, that's standard.
A standard form. It's just understood to have
B.
a 0 for the c value, which makes sense because my y-intercept is 0, 0. They're all connected. We cannot ignore anything we've studied in the past. We want to notice that these things connect. As I said, you're going to get a review of what we've studied in the past with these current units. Take advantage of that to learn and grow. Yes, Anthony, you will have to think for my class. So, hopefully 7 shouldn't take us long. Please notice, identify the zeros of j of x. Which function is j of x? Which one?
J of X?
Say it loud. The parabola, right? That red function was j of x, right? J of x equals all of this. So, identify the zeros of j of x. How are these related to the two linear factors? I'm going to just give you all a minute. We're going to come back together. Figure out what your zeros are for the parabola. And let's get going.
These related to the linear
Sir? Huh? I guess I just didn't ever cool down from working out this morning. I don't know.
It's so cold. It was good at first.
Uh-huh.
Because they jammed me.
It's not a joke. Alright, let's bring it back. So what are the zeros of j of x?
0, 0, and negative 3, 0.
Okay?
Right
0, 0, negative 3, 0.
Yeah.
Okay, so I want to modify, or I want to push on this a little bit. Does anyone want to know why I want to push on those two responses for the idea of zeros?
Why? Why you want to push back on that?
Yeah, that's what I'm asking. Anybody have an idea?
Is it because it's
Okay, I'll say it this way. The zeros are involved there, but I would not call those zeros. I would call those something else.
X-intercepts.
Please remember, these are x-intercepts.
So, 0
So what-
and x-intercepts are not the same thing?
They're not exactly the same. A 0 would be when we say x equals something. So what would I say for the zeros here? X equals 0
X equals negative 3.
and x equals negative 3.
Dang.
Zeros are another term for roots. And so just the root is what I was looking for there.
Okay. Now
Yep.
I know. Now we know.
So I will point this out because I do see this on yours, Mitria. You would say R1 is equal to 0. You would say R2 is equal to negative 3 for the roots. This is what I'm looking for, x equals when it comes to zeros. Right? Now I will remind you, does anyone know why we call these zeros?
why?
Because the y is always what?
0.
Right. So what I'm asking when I say 0, right? I'm asking, hey, I'm looking for x values when y equals 0, right? So I'm looking for those x values when y is equal to 0, where y is equal to 0. That's what I mean by 0. Okay? But here's the important question. How are these zeros related to the two linear factors?
They're both.
Oh, because the current function is, I was about to say.
They both create a.
Yeah.
I'm just circling those, right? Just to point those out graphically.
Okay, it's the x value for is the x value for both of the lines. For the y equals x and the x value.
Kind of what were you going to say?
They
Kind
share the same X
X what?
intercept. Yeah, X intercept.
So the zeros for the parabola are the same as the x-intercepts for the what? What are those called? It's in the problem or the question.
Zero.
Linear.
There we go. Thank you. That's what I'm looking for. Linear factors. So we'd want to note, right? The zeros from the parabola j of x are the, and really x values of x-intercepts for the linear factors. We've got to notice that the zeros are just the x values of the x-intercepts for the linear factors. There's two quick things I want to point out about this. First off, wait a second. Bless you. What's the factored form?
Factor form is a x. No, parentheses. X minus R1, and then x minus R2.
Hey, what could we call these two things right here?
Huh?
What can we call these two things right here?
Roots. Zeros. X-intercept.
Think about what we just talked about, number 7, and what we wrote up here. They're linear factors, right? Could you graph this?
Yeah.
And what would you get?
A parabola.
Just this part.
No, we get
So, do you need to say a linear line?
Linear.
Factor.
Linear function or just a line? Right? If I graph y equals x minus r1, I would get a line, wouldn't I?
Right.
If I graph y equals x minus r2, what would I get? A line. But those linear factors are also what give me my roots or my zeros. So we've seen, this is not brand new information, this is what we've always seen. The linear factors are what give us our roots.
So what does linear factors mean? Like
That's
what
a
it-
fantastic question. Anybody have a guess?
Factors that create.
Ah, what do we mean by factors? That's what you want to notice, right?
Like constant.
What do you do with factors?
You
You multiply them. So these are called factors because they are being multiplied. But if you were to look at just this factor, it would be a line. Right? If you were to graph just that factor, it would be a what? Line. Notice how it's x to the first? Just like y equals mx plus b. X is to the first, so it would be a linear factor. Does that answer your question, Anthony?
Yeah.
So factors, remember, we just multiply with factors. We call it a linear factor.
Because it's two linear factors.
Right. It would both be lines. That's it.
But why wouldn't it be called a quadratic factor? Because it makes a quadratic.
Well,
Because it makes
the whole thing is a quadratic.
Oh, okay. Alright.
But just that is linear.
Alright.
Right? Okay. Where did I put it? There it is. What are your questions before I continue forward? Going once. Going twice. Sold. Huh? Good. Alright, we have got to finish up this lesson, this activity right here. So, I'm going to more directly lead this. So, two quick things I want to remind you. So, the graph shows the product of the linear factors used to create the new function. As you analyze the graph from left to right, consider that the new function j of x changes from decreasing to increasing at this point. So boom, there's that point, negative 1.5, 2.5. What do they mean that it's changing from decreasing to increasing? That is wrong.
I was about to ask you.
Okay, why are you about to ask about that?
Like, no, I was gonna ask, what do you mean, like?
Okay.
Yeah.
So first off, we defined this before, but this should be from increasing
To decrease.
to decreasing,
Okay, okay.
is what it should say. I don't know why the textbook is wrong there. So what do we mean that the function is increasing?
The x-intercepts are increasing and
Time
the
for-
y's are decreasing.
For parabola, because they going upward.
So we're talking about the function increasing versus the function decreasing. Now, need you to be careful, Anthony. How do we always read a graph?
Left to right.
Left to right.
So the x always,
The x are always what?
increasing.
The x are always increasing. We're not talking about increasing x values. We're talking about the what?
Why?
The y's. Remember, the function really is talking about those outputs, right? So, Caitlin, what were you asking a second ago?
No, I was saying for, increasing, the function will increase.
The function increases to start because notice, what are these y values doing? They are going,
Increasing.
they're going
Up.
up. So I just want you to notice it's increasing because those y values are going
Up.
up. That's it. And we're going to talk about that in a second. But notice over here on this side, the y values are going
Down.
down. So it is decreasing. That's why it's from increasing to decreasing. Okay? So, notice we're considering the interval between x equals negative 10 and x equals negative 3. So that's from here to here. That's what we're considering. I'm going to focus on why the function is increasing first.
Because
So
the
why is the function, so,
The y values are going up.
right, the y values increase. Like that's what we want to notice. The idea of increasing or decreasing is not talking about the x values, it is talking about the y values increasing. That's what we want to focus on. Okay? Now, the other part up here is explain why the product of the linear factors results in j of x being negative. So for example, right here, that is the point, negative 4, negative 4. That y value is the product. Why is that product of the linear factors negative?
Because it's below the y-axis.
Okay, so we know it's negative because it's below the y-axis, but have you talked about the linear factors at all?
No.
Let me ask you this, what is, actually that's not a great point to use. Let's look at this one right here. Is that y value positive or negative?
Negative.
But there's also a y value up here, is that positive or negative?
It's positive.
What's a positive times a negative?
Negative.
So all of these values are
Negative.
negative because it's a positive times a
Negative.
negative. So that's what we want to notice. Y equals negative x plus 3 is positive there. But y equals x is negative. So the product is what?
Negative.
Yep. Okay. So then we're going to look at negative 3 to 0, but the time is going to catch us. I'm not going to show you the homework because we haven't gotten far enough for you to be able to do the homework yet, but there will be homework due on Friday. We'll pick back up here tomorrow, but I do want to point out j of x is positive here. Why are these numbers positive if we look at the linear factors?
The x-axis.
Because they're both what? Right, but look at the linear factors. Why are these positive? That's,
Because they doing, negative times a negative.
isn't that a negative times a negative?
Yeah.
And what's a negative times a negative?
Positive.
Positive. Remember, it's not just about, hey, the parabola's above or below. It ties into those linear factors. As I said, I'm not showing you the homework yet. I'll put it up, I guess, briefly, if you want to look at it, just so you know what's coming down the pipe. Actually, I guess you could do those two graphic organizers. Or at least the first one. Have a great rest of your day.
I'm breaking out lesson 3 so I can work on it, because I can't do anything right now.